today we are going to look at section 1.4, which is over increasing or decreasing intervals, extrema, and average rates of change. So we're going to start with whether a function is increasing, decreasing, or constant over a certain interval of the graph. Now if we look at this first example up here, it shows us what it looks like when it's increasing, constant, or decreasing. So for this first section, we always read from left to right. So starting at the left, so we're starting at negative infinity because that's an arrow. So from negative infinity up until here, the graph is increasing. And you're always looking at what x value the behavior changes. So it's going up until it reaches the x value of -5. So then that first interval would be from negative infinity to -5, and that part of the graph is increasing. Then it changes from increasing to constant. So from -5 to an x value of 0, the graph is staying constant. The y values are not changing. And then from 0 on to the right forever, so that's infinity, the graph is going down or decreasing. So from 0 to infinity, the graph is decreasing. So we're going to do that on a couple more graphs here. So for this first one, it asks over what intervals, and remember, that means what x value intervals is the function increasing, going up, decreasing, going down, or constant. So let's start with the first section of our graph. So we see an arrow on the left, so that means we're starting at negative infinity, and we're going to an x value of -1. So that means the first section of our graph, from negative infinity to an x value of -1, the graph is decreasing. Then we take a look at the next section. So here's the next section of our graph, and that one is constant. Now, as far as the x values, so it is constant from an x value of -1 to an x value of +2. So that's our next interval, -1 to +2. So -1 to +2, the function stays constant. And then the last section of our graph, we can see going from left to right that it is going up and it ends in an arrow, so that's infinity. So at an x value of +2, it begins increasing, and then it increases forever and ever from then on. So we have from +2 to infinity, it is increasing. Okay, let's take a look at the next one. So for this first one, so this is all curves, but we do still have points at which the behavior changes from increasing to decreasing to increasing and back and forth. So for our first section, remember, always start from the left and work your way to the right. So from the left, I start here and I've got an arrow and it's going up until it reaches this point right here. So at this point, it ceases increasing and it changes to decreasing. So we can say that from negative infinity to an x value of +2, the graph is increasing. Then at that point it changes to decreasing, and it decreases until here. So at this point it changes from decreasing and it starts going back up. So we have from 2 to 4, the graph is decreasing. So when x is 2, it begins decreasing, and when x is 4, it stops decreasing. So that entire section of the graph is decreasing. And then from that point on, it is going to be going up, which is increasing. So from positive 4, so right here, x is positive 4, on to infinity, the graph is increasing. So when you are writing intervals for increasing, decreasing, or constant, make sure that your intervals are always using the x values. Okay. Now, we're also going to talk about these points where the behavior of our graph changed. And those are called extrema. So we're going to move on to that now. So we call those minimums and maximums, turning points. So where the graph turns, so it changes from increasing to decreasing, that's a turning point. Or it changes from decreasing to increasing, that's a turning point. So anytime that behavior changes from increasing to decreasing or vice versa, that's called a turning point, and we call it a minimum or a maximum. Now there are two types of minimums and maximums. You can have absolute maxes and mins, or you can have relative maxes and mins. So absolute max and min is exactly what it sounds like. It is the absolute highest or absolute lowest point on a graph, meaning there is no point higher than an absolute maximum, and there is no point lower than an absolute minimum. Now a relative maximum or minimum means it is the highest or lowest point within a certain section of the graph. So not overall, there can be a higher point, just not within that immediate section of the graph. So if we take a look at our turning points on this first one, we have a turning point here because it changes from going up to going down. So that's a turning point. And then we have changes from going down to going up. So that means that we have another turning point right here. Now, if I take that first turning point that I found, so I have this one right here. So that turning point is the highest point in this section of the graph. So within that little section of the graph, there is nothing higher. Now, there are higher points on the graph at some point, but not in that particular section of the graph. Therefore, this is going to be a relative maximum, not an absolute, but a relative. And that relative maximum point has a y value of -1. So that's that point right there. Now, it's not an absolute because all of these points in here are higher, but this is the highest point in that particular section of the graph. All right, now if we take a look at this turning point, well, that one is the lowest point in this little section of the graph. Not the lowest overall, but the lowest in that section. Therefore, this is a relative min. And the y value at that point is -5. Alrighty, now for number 2. So for this one, we actually do have an absolute point. We have an absolute maximum because even though these points are exactly the same height, there are no points other or higher other than those. So we say that those are absolute max at a y value of, and the y value at those points would be 4. So those are absolute maximums because there is nothing higher on the graph. Now, we have another turning point, which is right here. That turning point is a low point, but it's not the absolute lowest point on the graph because all of these points down here are lower, but it is the lowest in that particular little area. So that one is a relative min, and the y value there is 3. So for number 1, there is no absolute maximum and there is no absolute minimum because that graph continues to go down forever and up forever. So you can't hit an absolute highest point or an absolute lowest point. Number 2 has an absolute max, but it does not have an absolute min because, again, that's going to keep going down forever. So there is no absolute lowest point. Okay, so those are maxes and mins. Now, the last thing that we want to talk about is going to be average rate of change, which is really just the same thing as slope. So we need to remember our formula for slope, and that is m equals y2 minus y1 over x2 minus x1. Okay, so that's our basic formula for slope that we've used for years, and it is the exact same thing as rate of change. Now, the one difference in finding the rate of change is that when we're asked to find the average rate of change for a function on a specific interval, they are going to give us the x values. They did not give us the y values. However, if I've got a function and I have an x value, I can find the y value that goes with it by simply plugging it in. So you're going to have to find your y values by plugging in your x's. So when you have your interval, this is going to be your x1, this is going to be, oops, not y, this is going to be your x2, and you have to find your y1 and y2. So we're going to plug those in. So we're going to start with our x1, which is negative 2. So we're going to take our function and we're going to plug in negative 2 because that's our first x value. Now our function is negative x cubed. So it's negative, but then x is negative 2, and that's cubed, plus 3 times x, which is negative 2. Well, if I cube in negative 2, I get negative 8, but then I have this negative, which changes it back to a positive 8. And then 3 times negative 2 is negative 6, so I get 2. That 2 is my y1. Since this was my x1, that means my answer is my y1. So I have a point of x1, which is negative 2, and y1, which is my answer, positive 2. So these are what I'm going to use in my slope formula. That's my first point. Now I need to find my second point. So I'm given the x value, and the x value is negative 1. That's the second number in our interval. Now I'm going to plug that into my function. So negative, and then x is negative 1 cubed, plus 3 times negative 1. Then do the math. Negative 1 cubed is negative 1 times another negative is a positive 1. And then minus 3 gives me negative 2. So that's my y2 because this was my x2. So then my next point is x2, which is negative 1, y2, which is negative 2. So now that I have my 2 points, I need to find my slope. So using my basic slope formula, m equals, I have my y2, which is, let me label these, x2, y2. Okay, so I have y2 is negative 2 minus y1, which is 2, divided by x2, which is negative 1, minus x1, which is negative 2. So then that gives me negative 4 in the numerator, and then that's negative 1 plus 2, which is just 1. So my slope comes out to be a negative 4, and slope is the same thing as average rate of change. So average rate of change equals negative 4 over that specific interval. So we're going to do one more of those. So I want you guys to pause this video real quick, and I want you to try number 2. And then once you've got it, go ahead and start the video again, and then I'll walk through it and make sure that we all got the same thing. Okay, so just like on the last one, we are given our x1 and our x2, so we need to find those y values. So we're going to start by plugging in our first x value, so we're going to do f of 0. And remember that our function was negative x cubed minus 3 times x. Well, that's just going to come out to be 0. So that one was pretty easy. So our first point is 0, 0. That's our x1 and our y1. Now I can do my second point. So my second f value was 1. So then I have negative 1 cubed plus 3 times 1. So then that's going to give me a negative 1, because 1 cubed is 1, and then make it negative is negative 1 plus 3, that gives me 2. All right, so that gives us our second point is 1, 2. So that's my x2 and my y2. So now I can do my slope. So for slope, remember it is y2 minus y1 over x2 minus x1. Therefore, we get 2 over 1, which is just 2. So our average rate of change is 2. Alrighty, and that is the end of section 1.4.